You know how sometimes the tiniest little clue can just blow a whole story wide open? Well, that's what we're doing today. We're going to take one single, kind of cryptic line of text and use it to unlock the hidden science of, well, science itself. It's going to be fun.
All right, take a look at this. Unless you read Mandarin, it probably looks like a bunch of random characters, right? But I'm telling you, this isn't just text. It's a secret map. It's a footprint left behind in the huge, sprawling world of human knowledge. And right now, we're going to be detectives and decode it together.
So, where do we even begin? Well, let's start at the beginning. These first characters, Bu Yaqun, Li Shuangshuang, those are names. Specifically, Wu Yaqun and Li Shuangshuang. And just like that, our mysterious line has people behind it. We found the creators. That's piece number one of the puzzle. Okay, next up, what were they even doing? Well, the next part of the puzzle translates to development and trend of geography research in Chinese universities. So, boom, now we know who wrote it and what they were studying. See, the picture's already getting a lot clearer. And for the final piece, 纪理学报. This tells us where this research was published. It's a journal called Acta Geographica Sinica, which is a big deal in the Chinese geography community. This gives their work a home, a context, and a stamp of credibility.
So let's just do a quick recap of our little investigation here. We started with what looked like gibberish, and in just a few seconds, we turned it into real, solid information. We found the authors, we figured out the topic, and we know the publication. We cracked the code. But what's really cool is that this whole process, it's part of a much, much bigger idea.
Yeah, the simple act of breaking down a publication, not just reading it, but treating it like a piece of data. That's actually a whole scientific field. And it has a pretty cool name. It's called bibliometrics. You can think of it as the science of science. It's a way of zooming out, way out, to see the entire forest of research instead of just focusing on one tiny tree. It uses statistics to literally map the landscape of human knowledge, all by looking at what we publish. But you might be asking, why would anyone do that? Why bother analyzing millions upon millions of papers? I mean, what's the point of trying to measure science on that massive, almost unimaginable scale? Well, it turns out the answers you get are incredibly powerful. This is where it gets really interesting. When you analyze millions of these data points, you start to see the big picture. You can spot emerging trends, like seeing the first whispers about gene editing years before anyone was talking about CRISPR. You can literally map how scientists in Brazil are working with teams in Japan. You can even watch an idea jump from, say, a physics paper and end up in cancer research. And this isn't just for fun. This is the kind of intelligence that helps governments and universities decide where to put billions of dollars in research funding. It's a huge deal. I mean, look at a simple chart like this. Imagine watching in real time as a topic like AI ethics or mRNA vaccines just explodes. You could actually measure their journey from a tiny, niche subject to a massive global priority. This is literally how we take the pulse of human innovation. And the scale we're talking about is just mind-boggling. That one little line we started with, it's not analyzed by itself. It becomes one single data point among millions, sometimes hundreds of millions. Every single publication is like one tiny pixel. But when you put them all together, you get this incredibly detailed, high-resolution picture of how science actually works. So let's go back and look at our line one last time. It's not really a mystery anymore, is it? Now we see it for what it truly is, a single, really valuable data point. It represents two people adding their piece to the puzzle of geography in a specific journal, all part of this gigantic, interconnected web of discovery. And all of this brings us to a really important idea. There's an old saying that what we measure is what we value. So by choosing to measure things like how many papers are published or how many times they're cited, we're basically saying that those things are what's most important for scientific progress. But are they? And that's the big question I want to leave you with. Bibliometrics gives us these amazing, powerful tools to understand how science works. But as our tools get sharper and more sophisticated, we have to ask ourselves a tough question. How do we make sure we're measuring what truly matters for the world, and not just the things that are easiest to count?